Okay, this is the geometry video lesson for 12.1. Tangent lines. So a tangent line, and this is with the circles. So this chapter is called circles. So here's a circle. A tangent line is a tangent to a circle if it just touches a circle in one place. So it just barely touches one there. This is called the tangent line. And then the point at which it touches is called the point of tangency. Tangency? Yeah, I said it right. Okay. And a tangent to a circle is a line in a plane of the circle that intersects the circle in exactly one point. Okay, so what do we know about tangent lines? We know that if there is a line tangent to the circle, then it is perpendicular to the radius from the center to the point of tangency. So you can see here, if we know that this is from the center to the point of tangency of the tangent line, then this is a 90-degree angle there. So that will help us solve problem 1. So if you're looking here, it's telling you that these two lines are tangent. So that means, and this is coming from the center, it's telling you that this is the center in a circle. You name a circle by the center. So this is saying point O is the center of the circle. So that means this is 90-degree angle and this is a 90-degree angle. So if we are going to figure out what X is, right, this is a quadrilateral, which means it has 360 degrees. So if we just subtract our two 90s and our 117, we should be able to get our X. And this is 63. So this is our answer. Okay, and remember, we know that this is 360 because we use our n minus 2 times 180 formula, and a quadrilateral, 4 minus 2 times 180 is 2 times 180, which is 360. Just a reminder from previous chapter. Okay, so here is one for you to try on your own. Please press pause, and then once you're finished, check back for the solution. Okay, here it's a triangle, so these add up to 180. Since this is tangent, then this is 90 degrees, so 180 minus 90 minus 38 is X, which is 52 degrees. Okay, moving on, here's a little bit of a word problem. Here's the CN Tower in Toronto, Canada. It has an observation deck of 447 meters above the ground level, and then it says about how far is it from the observation deck to the horizon? And the Earth's radius is about 64 kilometers. So let's draw a picture. Here is Earth. Here is a radius, and then here is the observation deck. So this is going to be 6,400 kilometers, and then this is not to scale, is going to be 447 meters. So this, let's add, what is K is 1,000, so this is 6,400 and then 3 meters. There we go. Okay, and then if we make a tangent line to this point here, we know that this is 90 degrees, so we can make a right triangle, and then this is my 64, or 6,400,000 meters. Okay, or let's make this all in kilometers, right? If we make this kilometers, this just becomes 0.447 kilometers, and let's just keep this 6,400. This will make the math easier. Okay, so what we have here is a right triangle. So we can do the Pythagorean theorem, right? It's asking about how far is it from the observation deck to the horizon. So this is the distance we're looking for. So right triangle is a squared plus b squared equals c squared. In this case, the c is this radius plus the height of this observation deck. So this is going to be, so c is 6,400 plus 0.447, and then that's squared. And then this is, one of our sides is x squared. We don't know what that is. The other one is 6,400 squared. Okay, so x is going to be the square root of this minus this. Sorry, I did that in pieces, but you guys know how these do, right? I'm going to subtract this from this, and then we take the square root to get x alone. So this is what we're going to put right in Desmos, and that makes it a little easier. And we get just about 75.6 kilometers. So the Earth's radius, the observation deck is about 56 kilometers from the horizon, or the observation deck of the tower is 76 kilometers from the horizon. Right. I don't know why you need to know that, but this is a word problem, a real life situation, right? Here's the tower, and then this is the length that we're looking for, horizon to there. Okay. And then here's one for you to try on your own. What's the distance of the horizon a person can see on a clear day from an airplane 2 miles above Earth? So then the height, right, the airplane's here. And then, wait, oh, this is in miles. I'm like, now the Earth's radius is about 4,000 miles. So you're going to set up the same picture and then still find this distance, but you're now in miles, and you're now 2 miles above Earth instead of 447 meters. All right, try this on your own and then check back for the solution. Okay, here, so when you redraw this picture with the 4,000 as the radius, right, this is 2 in miles, again, not to scale, very clearly. And then when you do the Pythagorean theorem to solve for the x, you get that x is about 127 miles. Okay, moving on. So here's another theorem. It's basically the converse to the one here before. If you know that there's a line that touches the circle in one point, and it is, wait, if the line is in the plane of a circle is perpendicular to the radius. All right, if there's a line that's perpendicular to a radius, then it has to be, that means it is tangent. So, right, you can see here, because this is 90 degrees here, this is going to be tangent. Okay, like, so that's what this theorem is saying. That doesn't really help us solve this problem, but this is, we're going to use the same thing here. This is the Pythagorean theorem. So this is asking, what's the radius here? So since we know this is 90, we can use the Pythagorean theorem to solve for this. And so remember, the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse, which in this case is 8 plus x. And then a, let's call that x squared, and then this is 12 squared. So we need to get x alone. So this is an algebra 1 problem. This becomes 144. When we square this, this becomes x squared plus 16x plus 64. And that is because, right, x plus 8 times x plus 8, if you FOILed it, right, the first 2 is x squared, the outside 2 are 8x, the inside 2 are 8x, and then the outside are 64. And then these together become 16x. So gotta brush off that algebra 1. And then this is actually gonna, oh, look at this, this is nice. Okay, we can subtract the x squared here and get, oh wait, let's not do that. I'm forgetting. The squared threw me off, right? We can subtract the 64 from both sides. That makes it better. And then 144 minus 64 is 80. And then 80 divided by 16 is 5. So x equals 5 here. Okay, nice and simple. Okay, try the red star one, which is next on your notes after this. I'm going to leave it on this page when you push pause so you can see the work here, but you're going to work on the next one. Press pause and try the red star and then check back for the solution. Okay, so if you did this one, you would have gotten x is about 5 1/3, so I rounded it to 5.3. Okay, problem 4. So this is now asking, is this tangent at L? And so to find that out, we can see if this is a 90-degree angle, right? So this is where we're doing the, we'll check that if the Pythagorean theorem works on these 3. And so what we would do is take the 2 shorter ones, so 7 squared, and square them, 7 squared and 24, and then add them together. Does that equal 25 squared? And then just do this in Desmos. 7 squared plus 24 squared is 625. Does that equal 25 squared? I think it does. Yeah. Yes. Okay, so the answer is yes, and it's tangent. If it's hitting it right at a 90, that means this is 90 degrees. Okay, so we're just checking to see if that's 90 degrees. So try this one on your own. Press pause now and then check back for the solution. Okay, and you can see here, when you check these two, they get to 65. This squared is 64. So they are not quite, it's not quite 90 degrees, which means this is not tangent. Okay, moving on, a new theorem. If 2 tangent segments on a circle share a common endpoint outside the circle, then the 2 segments are congruent. So here is a common point outside the circle. These are 2 tangents. That means these distances are the same. So you can say that these 2 are congruent. Okay, using that in a problem, it says circle O is inscribed in ABC. What is the perimeter of triangle ABC? Well, you can see here, this is a, these are tangents, which means that this is, I guess it doesn't say that they're tangents, but, Oh, we know, oh yes, we know that they're tangents because they are inscribed in the circle. Inscribed in the triangle, sorry, that's what that means. So just touching at this one point. So since this is 15, this is also 15. Since this is 8, this is also 8. Since this is 10, this is also 10. So then we just add those up together, right? There's 2 10s plus 2 15s plus 2 8s. So it's 20 plus 30 plus 16, which is 50 plus 16, 66 centimeters. That's a nice easy one. And here is one for you to try. Press pause, try this on your own, and then check back for the solution. Okay, this one was a little trickier, right? It says that it tells you the perimeter is 88. So you define this length, but you know that this length is the same. So when you write the perimeter, 2 15s, 2 17s, 2 x's together, when you add them together, you get the perimeter, which is 88, and then just use algebra to solve. So x is 12, and I guess we should have some units on that, 12 centimeters. Okay, and that is it, I think. Yeah, time for practice. Enjoy.